So today's learning intention is to represent 3D vectors as a system of unit vectors, basis vectors they can also be called, and to solve linear vector equations. So our National 5 Essential Skills are working with 2D vectors, vectors in component form, and working with fractions. So any vector can be written in terms of the basis vectors. They're called I, j, and k. Now I is the unit vector in the x direction with components 1, 0, 0. J is the unit vector in the y direction with component 0, 1, 0. And the vector k is the unit vector in the z direction with component 0, 0, 1. So these basis vectors are three mutually perpendicular unit vectors. That just means they're three unit vectors at right angles to each other, as shown on the diagram. You can see I, j, and k. So just think of them as the x, y, z directions. They're unit vectors in the x, y, z directions. So any vector can be written in basis form using these three little unit vectors I, j, and k. So for example, let's look at the vector 2, negative 3, 6. We can take those components and write them in the form. So 2 times 1, 0, 0. Remember that's I, that's the unit vector in the x direction. Take away 3 times the vector 0, 1, 0, and that's the unit vector in the y direction. Add on 6 lots of the vector 0, 0, 1, which is the unit vector in the z direction. And we can write that as 2 times the vector I, subtract 3 times the vector j, add on 6 times the vector k. So put more simply then, if I have a vector equation ia plus bj plus ck, then I take the numbers before these little unit vectors, and that's just the components of the vector abc. It's a lot easier than it looks just now. So let's try an example together. Example 1. So the example says the position vectors of the points P and Q are given by P equals minus I plus 3j plus 4k and Q equals 7I minus j plus 5k. So part A says express the vector PQ in component form. And then part B, find the length of the vector PQ. This is worth 3 marks. This is an old past paper question. So how do we get started? Well, first of all, we're going to have to work out the vector PQ. So first of all, the vector OP, the position vector of P, can just be simply written as minus 1, 3, 4. Now, these are just numbers before the vectors I, j, and k on the position vector P. So the number before I is just minus 1, the number before j is 3, and the number before k is 4. So let's now work out the position vector of Q. So OQ equals, again, look at the numbers before I, j, and k. We've got 7 minus 1, 5. So you're just taking this vector equation and converting it into component form. Okay, so how do we find what PQ is? So PQ is just now the vector 8 minus 4, 1. If I'm at P minus 1, what do I do to have to get to 7? I'm going to have to add on 8. If I'm at 3, what do I have to do to get to minus 1? I need to subtract 4. If I'm at 4, what do I have to do to get to 5? I'm going to have to add on 1. So from P to Q has the components 8, negative 4, 1. That's worth 2 marks. Now we have to get on to part B to find the length of this vector PQ. So to find the length again, remember, all we're going to do is take all the components, square them, add them, and take the square root. Now careful, for the marks in the exam, you have to write it all out. So it's the square root of 8 squared plus, now you need to show you know it's minus 4 squared. It becomes positive anyway, it doesn't really matter, but for the examination board you really have to see that written down, plus 1 squared. In your calculator that's going to give you the square root of 81, which would simplify to 9. So we've found out the length of PQ equals 9 units, but you can just leave it as 9. Example 2. Example 2 says if two forces are represented by the vectors F1, which equals 2i plus j minus 3k, and another vector F2 equals I plus 4k. Now, we'll be careful here a minute. You'll notice that there's no j component, it's missing, so that means it just must be 0. It says find the magnitude of the resultant force F1 plus F2. So all we're doing is adding two vectors together. So F1 equals, so why don't you put it into component form? F1 is the vector 2, 1, negative 3. Again, taking the numbers before I, j and k. F2 is the vector 1, 0, 4. Again, remember there's no j component, there's no y vector in the y direction, so it's 1, 0, 4. It says find the magnitude of F1 plus F2. So first of all, what is F1 plus F2? That equals 2 plus 1 is 3, 1 plus nothing's 1, and minus 3 plus 4 is 1. So the magnitude equals, again, take all the components, square them, add them, and take the square root. So I've got 3 squared plus 1 squared plus 1 squared, and take the square root equals the square root of 11. So now try these on your own. Question number 1. Calculate the length of the vector 2i minus 3j plus the square root of 3k. In question 2, the vectors p, q and r are defined as follows. So part A says find the vector 2p, take away q, plus r in terms of the unit vectors I, j and k. Once you've done that, part B, find the value of the magnitude of the vector that you've just worked out. So it's time now to pause the video, attempt that in your jotters and come back when you're ready to mark. Right, I hope you're ready to mark. Let's have a look at the answers. The answers to question number 1 is the magnitude, the length of the vector equals 4. And for question 2, for part A, the vector equals 6i minus 7j plus 6k. And the magnitude of that vector is 11. So how did you get on? It's time to self-assess your own progress. So let's look at your RAG status. So in your jotters, write down, are you red? Finding it hard, still not sure. Amber, okay, but can you let me know exactly where your mistakes are, if you've got any? And green's for go, you're good for this and you want to go on to some harder work in class. Now for extra practice, you could look at page 256, exercise 13N, questions 1 to 4 in your Heinemann textbook. So what have we learned today? Well, we've learned that any vector can be written as a series of unit vectors. AI plus bj plus ck equals the vector with components A, B and C. Now remember the note taking says take time to jot this down into your jotters.